Share. I have shared one Google Drive link. You all can open in this. Actually, in this folder, it contains like three datasets that I will cover in this session, and one notebook is for this. Okay. This notebook I will be using for this session. Okay. So I hope you all can download and upload in your respective drive, and parallelly you can follow me. So you all can download this drive and upload it on your respective Google Drive. Okay. So try to do. So moving to this session on linear regression.
Akshat, your screen is not
Uh,
visible.
uh, yes, ma'am.
Are you
Is it
sharing your
visible?
screen?
Yes,
Now
ma'am.
it's
I have
visible.
shared. Okay. I hope that you all have downloaded and uploaded uh, these files on your drive, and then let's start. So in this session, what I am doing here, I will be covering linear regression, and then I will move to multiple linear regression and polynomial regression. Okay. I will be following I will be considering three different data sets for this regression analysis. First one is a salary data set, next advertisement data set, and then house price data set. Okay. So first thing first, I will import some library that is required for our computation. First one is NumPy library, and then for reading the data set from the drive, I will be using uh, Panda library. And then for the plot, different plots, I will be using matplotlib library. Okay. So after that, hit in control enter, or directly you can play this play button. Okay. So next is to read the data file. So for the first example, I will be considering salary data set. Okay. Uh, you can follow this drive location, and then if drive and the data set I have uploaded here. Also, I have uploaded in the lab 3 section that here. Okay. So I'm copying this path. Okay. This drive path, and then uploading reading this data file. We all know that the last session it is also discussed that you have to choose one data frame, and the method is read underscore CSV. Okay. So you just have to pass here the path. So this method will read the data frame and print the data frame. So I have now the data frame is read properly, This data frame contain like price, area, bedroom, and bathroom, storage, parking. So in this data frame, we have to predict one, like what is the price of the flat. Okay, so let's read another data set. Uh, that is salary data set. Okay. So in data set, we have given years of experience and different salaries with the change in year. The salary is also increasing. That is linearly dependent. This one is year of experience is your independent variable and salary is your dependent variable. So for the simplest example, I will be considering this data set for this simple linear regression. So take this as store in the DF variable. We will store this in the DF variable, and then if we print the DF of head at some starting value, it will return some starting value. Okay, so in this it contain like year of experience and then salary of different years. So let's inspect this data set, what it contains and what does it have. We will take the shape of this data set, that is what is the size, number of rows and number of columns of this data set. So that will come from shape method. Sorry. So it contains 30 rows and 2 columns. Okay. So what else? One more thing, that is it contain null values? We have to check most of the data set contain null values. So we should check prior to implementing any machine learning. We should check that whether it contain null values or not. So that comes under that data cleaning part. So df dot is null dot return whether it contains null value or any redundant value or not. So can that it doesn't contain any null value, so it is returned as 0 and even salary is 0 and year of experience is also 0. So next is for our data is not require any data taking operations. Next is we have to prepare the data for the our model. Okay, so for that we have to like define dependent variable. Let x equal to x is the independent variable, and, we have to convert the given data set in the form of arrays. Okay, or matrix. So we have using numpy array, np dot array of dx, and then our 0 represents the our independent variables. Okay, so here it is a Python format. Here this represents your rows, and this after column represents the column. So I am taking zero column, that is year of experience as a independent variable. Here it represents independent variable. Next is y. Y is our dependent variable, that is a year of experience. So we have to plot, we have to store this in dependent and independent variable. So next is we have to plot this data. Okay. So for plotting we are using I am using matplotlib, and we have stored and have this as a PLT. Okay. So we can directly call PLT dot figure. Firstly, we have to specify the figure size. Uh, and then that will be 12 comma 5. Next we have to plot this in the scatter format. The x-axis we will pass the year of experience, and then in y-axis we will pass the salary, and then some other parameter like size of the scatters will be 300, and what else we can add? We can add edge color. Can add edge color and line width. Okay, so PLT dot show. So this is the data set. Here x-axis represent the year of experience, and y-axis represent the salary. We can write, I think, PLT dot. So here we can see that this salary, this y-axis represents salary, and this one represents the year of experience. So here the idea is here that we have to put one line that after the center actually width of this data set. Okay. So for that we can fit one line that is called y equal to mx plus c. Here that is represented as y in the linear regression form. It can be represented as y equal to beta 0 plus beta 1, and of here b period, intercept, and volume slope. So for finding the beta 1, we will use this formula. Okay, this formula. And for beta 0, we will be using this formula. Y mean minus b cap x mean. Okay, so for that we can implement these things from the scratch, like x mean. First thing is we require x mean, and then y mean, and then x mean. So we need to find first mean. Okay, let's define our variable x underscore mean. Okay, uh, np dot mean. Using the numpy method, we can directly get the mean value of x. Okay. So actually we can write x comma axis is equal to 0. That is row wise. Okay. And the y mean is equal to MC dot mean. I comma equal to 0. Okay. So next is what we have to do is we have to find the beta 1 first. Okay. For beta 1 we have xi summation of xi minus x prime and yi minus y mean. Okay. So let's first we will do individually. Okay. Uh, beta b underscore numerator is equal to first thing first is we have to subtract x minus x underscore mean and then multiply it with y minus y of mean, and we have to sum all those things. So I will talk sum. Okay. So next is we have to perform the underscore denominator equal to minus x underscore mean. Uh, and then we have to perform the square operation. For the square we can get this, and then after that we have to sum this. Okay. So we will get this thing, numerator and denominator of beta. Beta. So the beta one is b1 is equal to b of numerator b underscore numerator plus b1 underscore denominator. So and after getting b1 we have to get b0. For b0 it is simple only. B0 is equal to y mean minus b1 star mean. So we have got beta 1 and beta 0. So next is we have to get one regression line. Okay, that's reg regression underscore line is equal to underscore y is equal to this one will give you beta 0 and plus this one will give you beta 1 and then of x. From this we have format. Format format b0 b0 comma round of b1 cross. So we have to run this. Actually, there is some issue with Google Colab server. It is taking time. So this is run now. Now we just have to pass x and y variable. Where is this small y? So we got y is equal to this and this. We got this properly. So up to here, I hope you all are able to follow. Let me save this code for you. The chat box and question. You all can copy this code and directly paste on your respective Google Colab notebook. So we got this. Next is we have to calculate the correlation. Okay. So for that we are using this correlation formula. Okay. We are going to implement this formula. First we have to find n. That is how we can get n. How we can get n? Can you type in the chat box? Hello, am I audible?
Yes, sir,
Yes.
you're audible. Yes, sir, you're audible.
Okay. Can someone type how we can get n? From our data set, we get n is number of rows. Okay. So for getting n, there are different methods. Length of x, we can get n, or like we have a method like df. We have data set df dot shape of 0. There are like different methods we can get n. Okay, n is equal to number of data points. So n is equal to length of x. So next is we have to formulate this. That is n into summation of xy and minus summation of x into summation of y. For that we can use directly. Let's suppose r of numerator is equal to n n into we have to do this x star y dot sum method, and then and also this. So next is summation of x, summation of x. We can do directly dot and then star and then y sum for denominator. And then for the y term we have to do some, we have to do some. So y we have to uh, So R will be equal to R underscore numerator divided by R underscore denominator. We can use this also. Okay. So run this and we have this solution. Okay, let's say I am pasting this code parallelly into the start box. So, uh, sorry, this should be my right. So here we can see the correlation and golden field. So it is nothing is part of the correlation coefficient. So it will be 97%. Okay. So next,
Akshat, your voice is breaking. Your voice is breaking.
now
There is some, there is some noise.
okay, ma'am. Hello. Hello.
Yes, you are audible now.
Next,
Hello. Hello.
Hello.
Hello. You are not audible, Maksud. You are just only presenting.
Achha, okay, ma'am. Now am I audible?
Now you are
Hello.
audible. Now you are
Okay.
audible. Start
Okay.
it.
Okay.
Start it.
Sorry. Here in this code, what I have done is I have written a simple Python code for plotting so that we can analyze that whether our regression line is properly able to fit on this our data set or not. So first I have taken uh, plotted scatter. That is scatter will plot this data points simply. Okay. Uh, Here in the scatter plot, I am passing two variables. First one is year of experience and next is salary of the employee. And here S represent the size of small scatters, and the for the outer black line, I am passing line width as 1 and the edge color as black. So this will be the scatters. So next line is the plot of line. So here we are plotting a plot for the this red line. So in this we are passing different parameter like x is the year of experience, and here it represents the equation that we have get from this beta 0 and beta 1 and x. This is the equation we have obtained, and we also know that this values and beta values. So and C represent the color of that line, and line width is the thickness of that line, and then alpha represent the like how much visibility you want, and then the solid this one is extra some uh, parameter. So next line represent the mean of that line. Okay. So and these are the some text I have used for this plot. Okay, you need not worry about this thing. And these are the title and labels of this. So here we can see that it is properly able to fit the proper line. Okay, and star represent here is the mean of the data set. Okay. So next, if we get some new data, how we can predict that whether what is the salary of the employee, and how we can do that. For that, I have written one function for that. That is def of predict of it contains different variable like beta 0, beta 1, and new of x. That is new of x is represent here. Uh, New year of experience. Okay, so we just have to pass three variables. We have beta 0 already, we have beta 1 already, and we just have to pass what is the year of experience for the new employee. Okay, so accordingly we can get the salary of the employee. So for that, let's suppose for the new year of experience, let's suppose 6.9 is the new year of experience for a certain employee, and then we have to predict the new salary. So the salary turn out to be this. Okay, 9,000, sorry, 90,900 something like that. So next, what we have to do is we have to check whether that this new year of new year of experience is able to properly lie closer or within the line. We have to check. So here we this is the plot. Ah, okay, sorry, it should be small, right? Yes. So it is here we can see that this yellow is represent the new year of experience, and it is able to fall on this line only. Okay. So next, for the sake of simplicity of this, I will be using mostly library for in use deploying this linear regression and multiple linear regression and uh, polynomial regression. Okay, so first thing is the linear regression model present in the scalar linear model. Okay, so first we have to import from scalar dot linear model, import linear regression model. Okay, so for that I am using first housing dataset. Okay, so firstly I will read from the dataset. uh, I have put my dataset here in the dataset, this directory. Uh, this dataset directory, housing dataset is here. Okay, this dataset contain different conditions like price of that flat and what is the area, bedroom, bathroom, store is and parking. Okay, so based on that, the price would be predicted. So how we can do using the linear regression? First, let's take the data set, whether it contain null value or not, what is inside the data set. We have to check. So this data set contain price, area, bedroom, bathroom, and different storage and parkings are there. So these contain total 545 rows. All are this, and no null values are not there for all the features, and data types are integer 64 bit. So so and the and in for the null value it doesn't contain null values. So let's prepare our data for the model. Okay, let's take area as our independent variable, and price as a dependent variable. So let's read this, and then reshape this in single vector, and next we will select one linear model test train split for the splitting of dataset and testing of the dataset. Okay, from the scalar model selection we are importing test train split. Okay, so let's split, run and split. Here I am splitting into 1 is to 3 form. Like some part of the data will be kept for training and some part of the data will be kept for testing. Okay. Next, I am initializing the model using the linear regression constructor, and then next I am fitting that X train and Y train data in this model. Okay. So let's fit. Yeah, it is done. So what next? I am predicting the values of X test. Next, what we have to do is we have to find the mean square error. Okay, to evaluate our model. Here we can see that this big error is coming. So next, let's suppose not to. So here we can see that this is not able to perfectly fit the line. So we have to do some more like we can go to multiple linear regression for this, for different, since it contain multiple uh, outliers and different data scatter format. So this is not able to fit for the single feature. Let's take another data. We will we will do some more regression in multiple regression also. Let's take another data set. Let's suppose advertisement data set. Okay. In this data set, this dataset contains like 4 rows. Okay, like how the sale is improving with the advertisement in TV, radio, newspaper sales. Okay, so let's check about what is inside the dataset. It doesn't contain null values. It has 20 rows. All are float type, and zeros are there mostly for null values. So let's see. In this, what we have in first column, we have TV. Let's ds2. Let's take first. Let's take first. What is the effect of sale when the advertisement is done only in radio? Okay. So for the radio, it should be one. That is 0, 1, 2. Okay. And let's do same for this. So for sale is -1. So we have prepared our data, and then next we will split this data set into test, train, and split. And next we have to call the constructor for the model initialization, and then we are fitting this train and test data. And next we have to predict the data, and then we have to find the square error. Okay, it is showing 5 5 error. Okay, next if we plot this, here we can see that it is still not able to perfectly fit it, in this data. Okay, this line. So if we take another feature like instead of radio, we have also newspaper advertisement also there. So let's take a newspaper advertisement that is available on second column, that is 0, 1, 2. Okay, so next is this. So for this error is also 5. So but we can see that it is also not able to fit properly. Next is TV. Okay, next for the TV, that is present at 0th in column. So let's see what is happening here. So the error is reduced from 5 to 2. So let's see how the our line is ever fitting. So here we can see that line is properly fitted, and we are able to see the line properly. Next is we have to find the correlation, that based on the correlation we can also apply linear regression and model selection. Okay, so let's see. I'm using C bond for plotting this. So here we can see that for the cell for the TV is in
Sir, this is a correlation matrix.
yes sir.
Okay, okay.
Yes, sir. So here we can see that for the advertisement in TV, the cell is 0 0.9, whereas for the radio, cell is 0.35, and newspaper it is 0.16, and so likewise. So if we take here feature for the TV, here I have taken cell for the TV. The line is perfectly able to fit. Okay, so this is the one of the example for linear regression. So moving to next is the multiple linear regression. In this is what we have to
Sir,
do.
when we were discussing about the error, so when you took TV, I think the error was reduced to 2%. So we can say that when the error is less, then the accuracy of the model will be more
Yes, sir.
with
We can
respect
say
to
that.
that.
Yes, sir.
Okay, sir.
Here we, yes, sir. Here I have taken mean square, root mean
Yes,
square
sir.
error,
Mean square error. Yes, sir.
root mean square error. Okay.
Root mean square RMSE. Okay.
Yes, sir. So up to here, I hope everything is clear. Uh,
Yes, sir.
So moving to next is the multiple linear regression. Okay, let's take again the house price prediction example for this, and read this data set. Since this data set contain like 1, 2, 3, 4, 5, 5 dependent variable and one independent variable. So let's prepare this data set for our model. Since we have already checked this data set, it doesn't contain any null value and doesn't have any different categories values. So we can directly prepare this data set for our model. Okay, let's x represent here all the column for the independent variable, and y represent dependent variable, that is price, that is present at the zeroth column. So next is we have to split this data set. Okay, so we have splitted this data set like this, that is 363 comma 5, that is these columns will come for the for all different x values, x this values, and this is for testing. Sorry, this is x train, y train, and x test, y test. Okay, this will go for training, and these values go for testing purpose. So for applying the multiple linear regression, it is quite simple, and it basically apply linear regression constructor only. So for that, first we will initialize this constructor and initialize this model, and then after that we have to fit x train and y train, these values, x train, and y train. Okay, and then next what we have to do is predict. Okay, so we have predicted, and let's find the multiple linear regression error. So the error is this, somewhat is more, but better than linear regression. If we see here, it is able to reduce some sort of error, I guess. Yeah, yeah, it is reduced from or it is go more. So if we plot this, we can see that it is here x-axis represent the actual and predicted value. So for most of the condition, if we check like this, that it is able to get good values. For some, it is not. So it depend on different data set, like how we are preparing. So for example, if we take, let's suppose this advertisement data set, it will show good results. So let's take for let's see for this uh, this advertisement data set, we have from 1 to -1. Next we will see the error here for this advertisement when we are using even single feature, that is 2. Okay, but for multiple regression it is showing 1.9. So it is better to use multiple regression when we have more features. Okay, so if we see the prediction of this, then what it will do? See here, only one data set is predicted as incorrect, but for more the data, for most of the data set, it is able to predict correct values as it lies on the this. Okay, like this for actually in the ground truth, for this first data set it is 5, and it is also predicted as 5. So multiple regression is better in comparison to linear regression, where we have to select single feature using the this correlation matrix. Okay, so moving to next is the polynomial regression. Okay, here in this polynomial, in the previously what we are doing is in this simple linear regression, we are just fitting the line from the data set. Now in the polynomial regression, we have to fit one line that passes through the data point. Okay, so for that, first we have in this um, scalar we have two polynomial features. That is, uh, we have to convert the features in the polynomial form, as this is discussed in the morning classes. Okay, first let's import. For right now we have this data set. Right now we have advertisement data set. Okay, right now we have advertisement data set. Okay, right now we have this advertisement data set. So here there are three columns for the for independent variable and one is dependent variable. So we have to convert this features in the form of polynomial. So here the degree should be 3. Okay. Okay. So in the polynomial regression, first we will transform this feature in the form of initialize. We will initialize first and then apply the transformation. I hope this is converted. Yeah, yeah, it is converted. Okay. Sorry, this one is dataset, and this one is mm, our main different data. Okay. So next we have to split this polynomial data set into test train split format. Okay. So this is converted, splitted into properly. Next we just have to apply linear regression in this converted data set. Okay. So here we have to just initialize the linear regression constructor and initialize the polynomial regression as a model. And on this we have to fit a test train dataset for the training. Okay. So if we run this, yeah, it is done. Okay. So next is we have to predict. So let's see the error. So error is reduced from like 2 to 1.9 to 1.4. So the this is the line that is perfectly fitted on this data set. So up till here, is there any question? Hello, hello.
Yes, Maksud.
Yes, ma'am. Let's read another data set. Let's take this housing data set. Let's see. We have to be. So currently I'm taking this housing data set. Okay. So for that here the that is a dependent variable present at first column. I am skipping this column and starting from one. In Python, the indexing is start from 0. So this one would be 1 to all this column. And for y variable, I will take zeroth column for the target variable. for this degree would be 1, 2, 3, 4, 5. Okay, the degree would be 5. So the degree would be 5. 5-degree polynomial, we should convert the data in the form of 5-degree polynomial. Okay.
Sir, what is the significance of fit transform, fit underscore transform? Sometimes we use transform, and why we use fit underscore transform?
Actually, it is given in this function. Okay, every function, like every constructor, have different techniques available for transforming the data. Sometimes it have fit, sometimes have it have fit transform. We can see that. Just wait. Like could be available in this. How we can call this polynomial feature uh, transformation. So how we can call this, like it should have different in the constructor we have different methods, like this is one of the method that how we can transform, like in case of, like it, see here it is given that fit transform method. Okay, there are different methods available for calling the constructors and different techniques. Okay, so no need to worry. You can like call the help method and like you can go through the documentation that what how we can call this constructor. Okay, so it would be easy.
Yes, sir.
Yeah. Next is we have to just split this data set. It is showing error. Okay. Just a moment. Yes, it is completely wrong. So it is split into 1:3 form. Okay, so two-third some part will be kept for testing purposes. So let's initialize this linear regression model, and here we are using fit function since linear regression constructor has fit method only. Okay, so next is the prediction. So what is the error here? I think it is still more. It has some issue with some this data set as this have outlier present, so it is not able to fit properly. So up to here, I hope you all are able to do on your respective notebooks. If you have any doubt, you can ask. Hello.
Sir, in when we write degrees, then we are considering features and target both, na? Like
No,
you've
no,
written
no.
degree equal to 5.
No, no, no. We just we don't have to consider target value. Okay, we just have to consider only independent values like this one, features, area, bedroom, bathroom, storage, and parking. Okay, these five I have considered.
Okay, sir.
है ना? So I have shared one the Google drive link and one notebook, you can also try to do. And if you have any issue, you can type in chat box. Okay. Uh, Swati ma'am, try with this link. Is it working? You all can use this notebook also for in case if you miss some code. So try parallelly. If you have any doubt, you can ask so that you have you know how to implement this linear regression and multiple linear regression and polynomial regression parallelly. First thing first, you should mount the Google Drive properly with your notebook.
Hello. Hello.
Hello.
Are you
Yes, ma'am.
are you there?
Yes, ma'am.
Are you presenting anything else?
No, ma'am. I have completed all this.
Okay, okay. Okay, thank you, Maksud, for your presentation. It's very clear to all. Maybe they have some doubts. They have cleared the doubts with you. So thank you very much once again.
Thank you, ma'am.
Okay,
Ma'am, I have shared this notebook also and this drive also in this chat.
okay. All the you have shared the drive link and notebook also.
Yes, ma'am.